You've taken the first and second derivatives of a function to learn about the shape of its graph. Use the following information to sketch the graph. And we're given the domain, the intercepts, asymptotes, intervals where the function's increasing and decreasing, local minimum and maximum points, intervals where it's concave up, concave down, all sorts of info. This is basically a graphing problem like the others, except we don't have to do all of the calculations. This is just asking us to interpret all of that information graphically. So let's pull up some axes and see what we get. All right, the first thing we note is that the domain goes from -7 to -1, and then -1 to infinity. So we are not looking to the left at -7. There's going to be nothing over there. And then there's some sort of a break in the domain at -1, but we'll look a little bit more at that later. For the intercepts, there's no x-intercept, which is interesting. There's a y-intercept at 0, 5, so we can plot that point. There are vertical asymptotes. There are 2 of them at -7 and -1. So I'm going to draw these in, -7 and -1. All right. Okay. And a horizontal asymptote at y = 2, which we must be approaching on the right-hand side because our graph doesn't go all the way to the left-hand side. And then what do we have? Intervals where f is increasing. It's increasing from -7 to -4. So something interesting happens at -4. Let's see. Oh, it looks like we have a local maximum at -4, -2. So we can actually plot that. That is our local maximum. And then we know that it's increasing from -7 to -4, and then decreasing from -4 to -1, and then from -1 to infinity. Okay. And we're told the concavity is upward from -1 to infinity. So we're dealing with upward all over here, and then downward elsewhere. Okay. So what is going on? Let's see if we can graph this. Let's look between the 2 points that we've plotted. Oh, right, there's also an asymptote. So let's look between -4 and -1. We've got this local maximum point, and we've got an asymptote, and we're told that the function is decreasing and concave down. So we can actually draw that in. We are decreasing and concave downward and asymptotic. And the interval to the left of that is similar, except increasing. So it looks like it's probably going to be similar, something like that, right? We are increasing from left to right, still concave downward. We knew this was a local maximum, so we're going to have a horizontal tangent line there. Potentially, we also could have a sharp point there. It might be that the derivative is undefined. It might be not a nice curve there, something else, but we don't know that. We know not enough information about the function to tell that, so I'm just going to assume it's a nice local maximum there and not something ugly. And then what else do we have? If we look at this point right here, we know that in this region, we are decreasing and concave upward, and we're also asymptotically approaching x = -1 and y = 2. So it looks like we are going to be going up here, and then as we go to the right, asymptotically approaching that. And it looks like it's going to be something like this. Also, we knew there were no x-intercepts, which is good. We haven't randomly given an extra x-intercept when we were told there were none. And it looks like our concavity matches, and I think we're good to go. So yeah, that's that.